I'm very happy to be here today and have this opportunity. I want to thank Marvin and ClearCreekAssociates for letting us bring this demonstration to you guys. The products have been in industry, but this is a new use for some of the products. We've got one that is currently NSF 61 approved for use in potable water supply systems and stuff, which is, well, we're very excited about having that approval already. The other product, the manufacturer has said that they will, if we can generate enough interest, they will go ahead and put forth the effort and the investment and finances and stuff to get it approved also. So we have two products that, you know, ultimately we will be able to use in these potable water systems. Some of the things, we did a demonstration in Kearney, Nebraska for the state of Nebraska's regulatory people back in February, I think. And this is one of the kind of things, I'll pass some of these around the table. This is just a kind of an eye-catcher thing. We're trying to find a use for this product, but it starts out with about 2 ounces of fluid, and then it foams up and becomes a stable foam. This is another.
You guys in other offices, you'll see this on the video.
This is another foamer. It's called their seal foam, and it's just a real, it's, you know, dehydrates a little bit, but we've had that since February that's been around, and it's a little bit more flexible. Anyway, I blended these up this morning, so they're ready to, you know, they're ready to mix in just two different, you know, mix the two parts together. And it's got a pretty quick set time on it. Should go off in probably around 10-15 seconds. And this is a one part here.
You can see that the consistency is basically water.
Yeah. And this is the Superflex that we're mixing up right now.
Okay. Quick. So you can see it's a little thicker, kind of like the milk. Disgusting. Report.
And you can control that between seconds up to several hours?
Yes. I'm going to leave a little bit in the cup here.
That sounds good.
You can see there that.
Wow. You got to pour it fast.
Yeah, you can see it, it's starting to change the colors. What that was, the demonstration was, it's just a piece of PVC, and I drilled 8-inch holes in there trying to represent a real small screen size so that you could see that it's actually, and you can, as you can tell, it penetrates well into the
I see it, yeah, that's what's impressive to me. I see it penetrates that finer sand fairly well.
Right. And I tried to get some finer sand and coarser sand so you kind of get an idea. And then you could actually feel it now.
Wow, this is cool.
Then the one we'll do now is the AC 400.
You can touch it, it won't hurt you. I wouldn't recommend eating it.
Which one was this going around?
Oh, this is Superflex.
This is the material that's
The
NSF.
non-neurotoxic one.
Yeah, neither one of them are neurotoxic.
So the difference with this stuff is it's a little more rigid and it costs a little less?
Yeah, this is, it doesn't have as much tensile strength or elasticity, then it's cheaper than the 400 is.
I see.
The disadvantage is that it doesn't have the NSF certification for portable water system.
Right. So you wouldn't use this, you would not use this in a portable.
No.
So the, is there a cost estimate on this stuff?
We figure that the kind of a ballpark on it, Marvin, it's going to be about $20 a gallon for the material that we actually get displaced. So, and then, because it's such a low volume of material, we don't make enough money on just the material to cover our costs for engineering. So we need to have a day rate charge on that. And we're looking at probably in the ballpark, $750 to $12.50 a day for day rate for engineering.
Plus the 20 gallon.
Yeah, plus 20 a gallon in that ballpark. You know, between $10 and $20 a gallon. And I realize that's, you know, it's kind of a wide ballpark, but it kind of depends on the volumes and shipping costs and everything to get it there.
And this material would work well in mine area where you're not concerned with the problem of water.
We're going off in the cut here too.
So are we on the, like, the lower end of that range with this stuff, or of the 10 to 20 bucks a gallon?
Oh, yeah, this would be the 10.
This would be the 10, the other ones
Yeah,
maybe
the 20, yeah, that would be the,
Not quite as much heat.
Yeah.
Well, at least my temple.
Yeah, it doesn't quite have the tensile strength that the others.
Yeah, I got it.
but, you know, you have to kind of look at you know, that's, you know, when you evaluate your wells and your candidates, you may not need the high tensile strength, so you may be able to go buy a little bit less, you know, more economical product. You may be in an environment that you don't ever foresee anything where you would need that real high tensile strength and high elasticity.
And you can see, what you were poking, and you can see that the material, even after it's set up for days and days, it's still pliable enough that if you had, you could pull your packers back through it for you. And then you could actually swab it out fairly easily without damaging, you know, as long as you didn't suck the screen in, you'd do okay.
This is our kind of the whiz-bang foam demonstration.
I've often thought that you might be able to use something like this if you had surface casing problems, if you had some leakage around the surface.
You know, or if you had casing that, you know, was gonna be a temporary casing that you wanted to pull out, you know, you could use this maybe as a surface seal on a temporary.
What is it made of?
Well, this is it's a polyurethane foam,
Okay.
basically is all it is.
Okay.
Is it relatively inexpensive?
Pardon?
Is it inexpensive? Do you use it instead of PVC?
Everything is about $10 a gallon. So, and I really don't, you know, to be real honest with you, I don't have an actual firm cost on it.
What is this that you're adding?
This is the activator on it.
You know what it's really good for?
Pardon?
You know what it's really good for? Does it get
Uh,
hot?
Pardon?
Does that get hot?
Oh, it just activates it.
It's really good for shipping fragile items. You
Oh,
put that
okay.
stuff,
Okay.
in a trash bag, then you can put your like electrical equipment. It's just when it starts to go, then you put your electrical equipment in it and then drop it in a box. And it'll completely
Oh.
encapsulate your
Wow.
equipment and take the shape of the box.
And then this one is, actually it's a water that activates it and gets it to go off. And it takes it a few minutes. You can see it starting to grow now if I'm not.
If that was confined, would it generate much pressure?
I don't know. I never asked on that, so I don't know. I don't think it would, you know, you probably get a little bit of pressure, but I don't know that it would be enough to do, you know, really hurt anything. But the first one we did with this, you know, we just, you know, Frank and I did this, and then the manufacturer's rep came out and showed us how to do these with, you know, a little bit bigger volume where it called, you know,